In this session we are going to study about capacitor and capacity of a capacitor, and then we'll look at the difference between capacitor and a battery. At the end we'll look at few applications of capacitor. So first, what is a capacitor? Capacitor is an electronic device which stores energy in the form of electric charge, and capacity of a conductor is nothing but capacitance. Capacity, when I say capacity, the ability of a capacitor is a physical device, and capacitance is the virtue of a capacitor. With the help of that, a capacitor stores energy inside it. So capacitance is a virtue, while a capacitor is a physical device. So capacitance is an electronic device which consists of two metal plates separated by a distance d, positive and negative plates separated by a distance d, and between these plates a dielectric is filled. So this is what a capacitor is. So positive charge on positive plate and negative charge on the negative plate. So we get a charge positive and negative by connecting a battery, because in general the metal is electrically neutral. So working of the capacitor we'll look at in next lecture. Here we'll just overview a capacitor and a battery. So now a capacitor stores charge, but a battery also stores charge. Then what does a capacitor, why does a capacitor different from a battery, or what makes a capacitor different from a battery? So it is basically, there are few facts about that. We'll try to understand the capacitor and a battery with the help of this example. So before we start this example, let's have a look of a battery. So battery, there is electrode, and there are two electrodes in battery. One is anode and other is cathode. Anode is one where oxidation happens, and cathode is one where reduction happens. So these oxidation reduction reactions along in the presence of electrolytes gives us the continuous supply of energy through the battery. So battery is actually huge source of energy. If you to understand this, I have written here two examples. If we consider a capacitor and a battery with the same dimensions are here 16 cross 35.5 and 10.5 cross 45.5. With these parameters, capacitance and the voltage, if we calculate the energy that a capacitor stores comes down to 0.58 joules. But if you calculate the energy which a battery usually have is 5071 joules. So the battery and a capacitor having the same dimension, a battery has almost 10, if you look at this example, 10,000 times much larger energy than a capacitor. So a battery is huge source of energy, but again both have different works and they are known uniquely great. So what makes a capacitor different from a battery? Let's demystify the concept, the underlying facts which defines a capacitor different from a battery. To understand that, let us consider a battery of potential voltage V, and let us consider we try to switch on this motor. So to switch on the motor, initial torque which we require is quite huge. So to start this motor, I am connecting a battery directly to the motor. What happens here? Motor doesn't start. Now I will charge, instead of directly applying to the motor, I will charge the capacitor by the same battery. So battery will supply energy and the capacitor is charged now to a potential difference equal to the potential of a battery. Now disconnect the battery and connect this capacitor to the motor. Now this capacitor is able to drive the motor. Even though it has same potential as a battery, but it can drive the motor. So what makes, even though they have the same energy, but capacitor is able to drive but not the battery. So why so? The very fact behind it is the rate at which capacitor gives the energy to the motor. Capacitor discharges energy at very high rate, which makes a motor to start. So that's the fact. So you can say the rate at which capacitor discharge is much more than the rate at which battery does. So you can say the capability of, so you can think of in terms of flashlight and all. So flashlight also discharge, when you switch on the flash in mobile phone, then capacitor discharges quickly at that time. So here, capacitor has high, capacitor can drive a motor but not a battery, even though they have the same energy. Now, another difference between the capacitor and motor is, capacitor is a passive device. First you need to charge the capacitor and then you use it for other purpose. So charge it through battery and use it. But a battery is active source of energy, because the chemical reaction inside it, which happens between the electrodes and the electrolytes at cathode and anode, gives us the continuous supply of energy. So that's another striking difference between capacitor and a battery, both being energy storage element device. So now we'll look at a few applications of capacitor. So looking at the application of capacitor, a capacitor can be used to remove noise, or a noise which occurs in IC design, in continuous power supply. Suppose we have an accelerometer IC. Here is the accelerometer IC. It has many pins. The one is VDD and the other is ground here. So these two pins are connected through a power supply. Here is power supply. So what happens when we connect a power supply to a accelerometer IC? There occurs a time through the power lines, voltage drops for some time, very short time. So to avoid that drop in the voltage through the power lines, what we do is a capacitor is attached between these terminals. So whenever there is drop in voltage, suppose the voltage should be constant versus time, but there comes a time when it drops and then moves up like this. So in that case, if you attach a capacitor here, this smoothens the curve and goes a straight line. So in the moment when it comes down, the capacitor keeps it up. So that's one of the application of capacitor in IC design. Now another application of capacitor is to remove the ripple in the electronic device. So let's consider adapter or charger. The normal working of the charger is it converts AC to DC. So if you look at the construction, we have something like this, and then you can connect a full wave bridge rectifier. So here actually our goal is to get DC output, but the output which we get at the end is something like this for full wave rectifier. But if you connect a capacitor to the output load, then the waveform changes to like this. So it smoothens the curve. The curve which we get now is smoother than, so it basically repels, it removes the ripple present in the DC output of the waveform. So that's another application of capacitor. Capacitor can also be used in audio amplifier to select a particular frequency for a specific purpose. So these are the few examples of capacitor.